Hi aspirants, welcome to AgriVision for you. So with the GATE 2025 examination, it's the time to practice more and more previous year question papers. So today in this video, we'll be going through the GATE XE 2019 questions. So this video, I'll be covering the first 11 questions and the remaining 11 I'll be covering in the next part. So before we dive in, if you are new to our channel, don't forget to subscribe and hit the bell icon to stay updated with our latest exam tips and preparation strategies. Also, don't miss out our exclusive discounts for our GATE 2025 batch. Click the link below for more details. Now let us begin. So question number 1. The colloidal stability of milk casein is because of the highly hydrated carbohydrate residues in. So options are alpha S1 casein, alpha S2 casein, beta casein or kappa casein. So alpha S1 casein basically it contains carbohydrate residues, but it is not highly hydrated as beta caseins and the kappa caseins. So it contributes to the micelle structure, but it plays a lesser role in the colloidal stability. Whereas alpha S2 casein, so similarly as that of alpha S1 casein, so in terms of hydration and contribution to the micellar structure, so it is less hydrated. Next, the kappa casein. So kappa casein basically it plays a crucial part. So kappa casein is a minor component of casein but has a unique structure with a hydrophobic and an hydrophilic region. Basically, the hydrophobic region it interacts with the interior of the casein micellar, while the hydrophilic region it extends outward and it interacts with the surrounding of the water. So this structure basically it helps to stabilize the casein micelle by preventing the aggregation and the precipitation. And additionally, this kappa casein it can bind to the calcium ions, which further contributes to the stability of this micellar. So therefore, we can say that kappa casein it contributes to the colloidal stability of the milk. However, kappa casein it is a primary factor which is responsible for maintaining the structural integrity of the casein micellar. So over here, my correct option will be D, that is kappa casein. Question number 2. Rice bran is stabilized prior to oil extraction to protect it from the activity of. So options are polyphenol oxidase, peroxidase, lipase or lipoxygenase. So over here my correct option will be option C, that is lipase. Lipase actually is indeed the enzyme that needs to be inhibited to stabilize this rice bran prior to its oil extraction, because this lipase it catalyzes the hydrolysis of the triglycerides and which breaks them down into fatty acids and the glycerols. So this can lead to the rancidity or the off flavor or the off flavors in the oil. So by inhibiting this lipase activity, the oil extraction with the oil which is extracted from the rice bran, it can be protected from degradation and maintain a higher quality. Whereas these other options, this polyphenol oxidase, peroxidase and lipoxygenase, these are also involved in the oxidative reactions, but they are less direct impact on the stability of the rice bran oil. So hence we can conclude that though this rice bran oil it is rich in nutrient, but it contains this lipase enzyme which can cause the rancidity in the rice bran oil by producing this free fatty acids. Those are FFAs. So this lipase, it should be inhibited enzyme. So my correct option is C. Question number 3. Sticking of the powder to the wall of the chamber during spray drying of fruit juice is due to first option, that is low glass transition temperature of the compounds in juice. B. High glass transition temperature of the compounds in juice. C. Improper processing parameters of the spray dryer. Or D. Presence of gums in feed material. So my first option, that is low glass transition temperature of the compound in juice. Acha, so first glass transition temperature, that is TG. So actually glass transition temperature, it is the temperature, is the temp is the temperature below which a material it becomes brittle or glassy. Is the temperature below which the material becomes glassy or brittle. That's why we say na glass transition temperature. So in context to this spray drying fruit juice, a low glass transition. So low glass transition means that the compound in the juice, it tends to solidify or it sticks to the surfaces, including the walls of the drying chamber. So over here, will be my correct option. Since low glass transition temperature means when the juice, it is atomized into droplets and it enters the drying chamber, what happens? It cools rapidly. So if the glass transition temperature of the compound in the juice is low, then they will solidify before they can completely dry. So hence it will lead to the sticking. That's why my correct option is A. Whereas high glass transition temperature means it would that the compound in the juice would remain in a more viscous or a liquid state for a longer time, now which will allow them to dry more completely before solidifying. And next one, that is improper processing parameters of the spray dryer means while this improper processing parameters, it can contribute to the sticking, but the root cause is often because of the physical properties of the juice itself, that is the glass transition. That's why this will also not be my most correct option. And last one, that is presence of gums. So gums can indeed contribute to the sticking, but they are not the primary reasons. Since the low glass transition temperature of the juice compounds is more significant, so therefore to prevent during spray drying of the fruit juice, it is essential to consider the glass transition temperature of the compound in the juice and to adjust the processing parameters accordingly. So this might involve the increase in the temperature of the drying chamber, or it can be using a different drying methods that can be better handle this materials with the low glass transition temperature. So over here my correct answer will be option number A. Next question number 4. Thiarubins and thiaflavins in black tea are formed by the oxidation and dimerization of. Options are quercetin, catechin, gallic acid, or camphorol. So this thiarubin and thiaflavins, these are the primary pigments which is responsible for the color and flavor of the black tea. Color and flavor of this black tea. Now, they are basically formed during the fermentation process of the green tea. leaves. So what happens? It involves the oxidation and then the dimerization of this catechin. So my correct option is B. Basically, this catechin, it is a group of flavonoid compound. So it is a group of flavonoid compound which is found in the green tea leaves. Now what happens during the fermentation process? This fermentation process, the enzyme that is polyphenol oxidase enzyme, it catalyzes the oxidation of this it catalyzes the oxidation of catechin, which is a flavonoid compound which is present in this green tea leaves. So what will happen? It will lead to the formation of the quinones. Now this quinones that can undergo the dimerization and the condensation reactions, so to form these thiarubins or the thiaflavins. Hope you got this point. Now option number A, that is quercetin. So quercetin, it is also a flavonoid compound, but it is not primarily the precursor of this thiarubins and this thiaflavins in the black tea. So this will not be my correct option. Next, gallic acid. So gallic acid, it is a phenolic compound. So gallic acid is my phenolic. It is a phenolic compound which is found in some of the plants but not in this green tea. And camphorol, it is another type of flavonoid which is not a precursor of this thiarubins and the thiaflavins. So therefore my correct option will be B, that is catechin. Question number 5. The ratio of Schmidt number to Lewis number is. So options are Prandtl number, Reynolds number, Nusselt's number, or Sherwood number. So this dimensionless numbers we have discussed many times in our classes also. So over here my correct option will be A, that is Prandtl number. So okay. So first, what is Schmidt number? So Schmidt number actually it represents the ratio of momentum, right? Schmidt number, it represents the ratio of momentum diffusivity to mass diffusivity. So it measures, it measures the relative importance of the momentum transfer to the mass transfer in a fluid. Next, Lewis number. So Lewis number basically represents the ratio of thermal diffusivity to mass diffusivity. It represents thermal so it is a measure of the relative importance of heat transfer to mass transfer in the fluid. Now what is Prandtl number? So Prandtl number basically it is a ratio of momentum diffusivity to the thermal diffusivity. Measure of relative importance of the momentum transfer to heat transfer in a fluid. So we can say that Schmidt number to Lewis number is momentum diffusivity by thermal diffusivity, which is a Prandtl number. So Prandtl number, it is momentum diffusivity by um, thermal diffusivity. And Schmidt number, it is a momentum diffusivity by mass diffusivity, and Lewis number, it is thermal diffusivity by mass diffusivity. So we have divided both of them and we got this Prandtl number. So over here my correct option is A. Question 6. Red dog is one of the byproducts during milling off. So options are corn, rice, ragi and wheat. So over here my correct option will be D, that is wheat. So wheat, red dog, actually it is used as a major source of protein and energy in the animal feed. So wheat red dog, basically it consists of the aleurone layer that lies between the bran and the endosperm, along with the small particles of bran, germ and the flour. So over here my correct option is D. Question number 7. An ice cream mix of 870 gram per liter has been used to prepare ice cream which yielded a finished product of 490 gram per liter. The percent overrun is how much? So the problem is asking us for the percent overrun of the ice cream. What are the given datas? Initial ice cream mix density 70 gram per liter. And the final or the finished ice cream mix density is 490 gram per liter. Now the percent overrun, it is calculated as weight of the mix per liter minus weight of the finished product per liter. The finished product per liter. It's percent, that's by 100. So just substitute the values. 870 minus 490 by 490 into 100, or it is 380 by 490 into 100. So it is 77.6%. So my answer is 77.6%. Question number 8. Impeller in a fruit juice mixing tank is rotating at 200 rpm with a Reynolds number of less than 10 to the power 4, density of the juice 1045 kg per meter cube. If the density of the impeller is doubled and the other condition it remains constant, the power requirement of the mixing will increase by the factor of how much we have to calculate. So impeller, it is rotating at impeller rotates at 200 rpm and the Reynolds number is less than 10 to the power 4, which is indicating the turbulent flow. Correct. And the density, it is given 1045 kg per meter cube. And the impeller's diameter, it is said that is doubled. So impeller's diameter is double, and other condition, it is remain constant. Now we are asked to determine the factor by which the power requirement of the mixing will increase. So for the turbulent flow, the power required for mixing in a stirred tank, it can be related to the diameter of the impeller, that is D. That is P, which is directly proportional to D to the power 5. This means that the power which is required, it is proportional to the fifth power of the impeller's diameter. Now, if the diameter of the impeller it is doubled, that means that the new power requirement, it can be expressed as new power. We can write it as d new by d old to the power 5 into d old, old power. So we'll get, and it is given us that d new, it is 2 times, which is doubled actually, the old one. So new power will be 2 to the power 5 into the old power. So it is 32 times of the old power. My answer will be 32. The power requirement, it will increase by the factor of 32. Next question number 9. Paddy, it consists of 20% husk. So paddy consists of 20% husk, which has been milled to remove 6% bran during polishing, and 6% bran, it has been removed during polishing, and no other losses is been assumed. So we have to calculate the yield percent of the polished rice. So the yield percent of the polished rice, it is equal to 100% minus the husk percent minus bran percent. Now husk percent, it is 20%, since they have said no other uh, losses is there, that is 20%, minus, and bran percent is, it is 6%. So it is 74%. So the yield percentage of the polished rice from the paddy is around 74%. Next, question number 10. Match the following laws in column 1 with the corresponding phenomena in the column 2. So Newton's law. So Newton's law, actually this law is related to the substance cooling, as it is describing the rate of heat transfer. So Newton's law is related to the substance cooling. Next, Hertz's constant stress theory. So Hertz's constant stress theory, actually this theory, it is related to the damage of the fruits and veggies during the mechanical processing. So it is Q, damage of the fruits and veggies. Next, Fick's law. So Fick's law, basically this law is related to the molecular diffusion, R4, which is actually the movement of the particles from the higher concentration to the lower concentrations. Last one, that is Bond's law. So Bond's law, this is related to the size reduction. So actually, as it explains the relationship between the energy which is required to break the particles and their size distribution. So over here my correct option will be A, that is P2 Q3 R4 S1. Question 11. Match the mold in column 1 with its asexual or sexual spore which is shown in the column 2. So first one, that is Aspergillus. So Aspergillus, it will go with Conidia. So actually this mold, it produces the Conidia. So it is basically a asexual spore. So that are typically born on the tip of the specialized structures which are known as conidiospores. Next one, Geotrichum. So this type of mold, it produces arthrospores, Q1. So this is also a type of asexual spore. So these are basically formed by the fragmentation of the hyphae. Next, Rhizopus. So Rhizopus, this mold, it produces sporangiospores. R. So this is also a type of asexual spore that are enclosed. So it is a type of. So they are enclosed within a sac-like structures which are known as sporangium. Sac-like structure. Last one, that is Oomycetes. So Oomycetes, these organisms, while these are often referred to as moles, so they are actually more closely related to this algae. So they produce the oospores. So they are actually the sexual spores that are formed within a specialized structures called oospongium. Oogonia. They're known as oogonia. Now, so over here my correct option will be A, that is P3Q1S2 and R4. So Aspergillus, that is Conidia, Geotrichum, Arthrospores, Rhizopus, Sporangiospores, and Oomycetes, Oospores. So over here my correct option is A. So with this we have completed our GATE Exit 2019 first part up to 11 questions. Next part, it will be uploaded soon. So till then, thank you and enjoy learning.